Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will look at the spanning tree, one of the most important algorithm called as Prince algorithm. Let us begin with the topic. The Prince algorithm is a greedy approach. What do you mean by greedy approach? We are going to find out the least possible value. That's the approach. That's why they name the greedy. You have the greediness to get another path also. This is very important. But you must remember, we don't include the cyclic path in the spanning tree. The greedy approach is for to get the greediness so that we have the minimum set of value. That's why the spanning tree is also called as minimum spanning tree. Let us look at once again. We have Prince algorithm is greedy approach to find out the minimum spanning tree. In this algorithm, to form a minimum spanning tree, we can start from any arbitrary vertex. This arbitrary vertex we are going to represent using R. Let us begin with the topic. So our algorithm is going to consist of graph which consists of vertices and edges. Then W represents the weight connecting the two vertices. Then R is going to be an arbitrary vertex. We also called it as root vertex. Let us go for the algorithm. For each U belonging to G dot V represents the arbitrary vertex. That can be any set of vertex. Then we have U dot key value as infinite value. It means that particular U is not reachable right now. Then we have U, that is another set of U as value as null. This value is taken as null. As we proceed further, this value will be calculated. Let us begin with the arbitrary root, that is arbitrary vertex which is represented by R. We have R dot key equal to 0. Then our Q function is going to be represented as G dot V, that is your vertex which consists of the graph. Then while Q is not equal to 5, that means it is not null, we can proceed with the further set of steps. We have U equal to extract minimum of Q. So we get the Q and we extract the minimum. So this minimum value is transferred to the variable called as U. Then for each V vertex belonging to G dot adjacent. Now this adjacent, we are going to use the adjacency matrix of the U. Once this is done, then we check with the another if condition. We have if each V belongs to Q and weight of U comma V is less than V dot key. So V dot key is value is taken as 0 for the starting point. If it is less, then we go with the condition. We have V equal to U. So the vertex which is under consideration, that U value is transferred to V. Then comes the last step, that is V dot key value will be weight of U comma V. So the weight which is between U and V is transferred to V dot key. Like this, the value of V dot key is calculated by taking the consideration of weight between the U comma V. We must remember we are doing the Prince algorithm for the minimum spanning tree, and this approach is a greedy approach. I have defined a class named as Prince. Inside that, I have defined an array called as unsettled. Now it is very important to know the return type of the array. You must remember, in this case we have the return type as boolean. So what do you mean by boolean? It is going to return me as either true or either false. So one of the value will be coming up as the return type, that is true or false. In similar pattern, I have another set of array called as settle with the same return type called as boolean, whose access specifier are very important. These are the access specifier. Both are going to be private. Now we look at another set of variables. We have number of vertices. Then we have the adjacency matrix. Since we are using the concept of adjacency matrix memory representation of the graph to represent the Prince algorithm. In case of adjacency matrix, the matrix consists of rows and columns. So we have adjacency matrix with rows and columns. Then we have another array called as key to store the key set of vertex. Then in these cases, we need to find out whether the vertex is reachable from the given set of vertex. That is, whether the vertex under consideration is reachable from the source vertex. If it is not reachable, we are going to use the value called as 999 to indicate that it is infinitely distance. So we write down public static final infinite variable of the type integer with the value 999. 999 indicates it's a unreachable. Then we have another array called as parent. These are the set of values we need to define first. This consists of set of arrays and few set of variable. Now we'll go for the constructor of the class. We write down public prims constructor with the parameter number of vertices. Now we will pass on this value. We have this dot number of vertices. To pass this value, we have this dot number of vertices equal to number of vertices. So number of vertices are taken from the user and passed on to the variable called as number of vertices using this reference. So we write down this dot number of vertices equal to number of vertices. When this is done, then we need to define the size of the arrays we have declared. Let us begin by one. We have unsettled equal to new boolean number of vertices which is taken from the user plus 1. So unsettled arrays created of the type boolean with the size as number of vertices plus 1. In similar pattern, we have settled equal to new boolean number of vertices plus 1. Now we will go for the size of the adjacency matrix. The matrix consists of rows and columns. So we write down adjacency matrix equal to new int number of vertices plus 1. This is going to act for the rows, and number of vertices plus 1. This is going to act for the columns. When this is done, in similar pattern, we are going to define the values for the key and parent array. We write down key equal to new int number of vertices plus 1. So this will be the size of the key array. In similar pattern, we have parent equal to new int number of vertices plus 1. So we have defined with the set of arrays and its set of size. So up till now, we have defined with the set of arrays which are needed to calculate the Prim's algorithm value. Now we will define the functions to get the count. It is very important to have the count. Let us begin with the topic. We write down public int get unsettled count. As the function name suggests, we are going to try to get the unsettled vertices count. So we write down the function as get unsettled count with the parameter as boolean unsettled array. So we have the unsettled array of the return type boolean. Then we write down the count variable value as count equal to 0. So our starting value is going to be 0. Then we once add the variables, that is once we start counting, it will be added to the count variable. Let's take example, count value is 1. So how it is going to be calculated as count equal to count plus 1. Previous value of count is 0. Now we add 1. So it becomes 0 plus 1. So now the value of count is 1. Like this we are going to add the value. Let us begin. We have for int index equal to 0. Index should be less than unsettled array dot length. We have defined the unsettled array. We are going to calculate its length, and index has to be less than this value. Then we go with the checking. We write down if unsettled with the index value starting from the 0. Whatever value of this comes out to be a true value, because we have the return type as boolean. So once this comes out to be true, then we increment the value of variable called as count by writing count plus plus. Once this set of values are done, this function will return the count variable value. We write down return count. Let's go for the another set of function. We have function called as Prim's algorithm. As the name suggests, it is the logic of the Prim's algorithm which we are going to write into this particular function. Since we are going to use the adjacency matrix concept, the parameter passed to this function is going to be adjacency matrix. We write down the function public void Prim's algorithm with the parameter int adjacency matrix. This is the array. Then we write down the another set of variable called as evaluation vertex. Once this is taken, then we will start with the source. Now in our case, we are going to start with the source as 1. So we write down for int source equal to 1, source less than equal to number of vertices. This number of vertices are defined by the user. Once this is done, we have already found out the source. Now we need to find out the destination. For this we are going to write down for int destination equal to 1, destination also less than equal to number of vertices. So both source and destination has to be less than number of vertices. When this is taken up, then we need to pass on this value to the adjacency matrix by using the reference of this. So we write down this dot adjacency matrix with the parameter as source. So source will act for the rows and destination, this will act for the columns. And we take the value as adjacency matrix, source, destination. So source, destination address of the adjacency matrix is passed to the adjacency matrix taken from the adjacency matrix of the user. This is how you transfer the value of the adjacency matrix, source and destination taken from the user to the particular reference array called as adjacency matrix with the particular set of source and destination. We write down for int index equal to 1, index less than equal to number of vertices. If this is less than number of vertices index, then we need to transfer the value of infinite, which we have taken as 999, indicating that it is unreachable, to the keys. We write down key index, that is the index number taken, equal to infinite. So this value is what? 999. So key index is going to be 999, indicating that it is unreachable. If this condition doesn't hold true, then we have another set of values. We write down key 1 equal to 0. Unsettled 1 index is true and parent index number 1 is going to be having value as 1. This is to get the set of values. Now we will check with the while condition. We have while get unsettled count, which we have defined with the parameter unsettled not equal to 0. It means there are some node to be calculated, or I can say some vertices that needs to be visited. While this condition is true, we are going to go for the algorithm. We write down evaluation of vertex equal to, we call a function called as get minimum key vertex from the unsettled. As the name suggests, we are trying to get the key value vertex from the unsettled, which is of the type minimum. So we have the function as get minimum key vertex from the unsettled. So obviously we are going to pass the parameter as unsettled. When this is done, we are going to define the another set of values. You must remember we have defined the return type of unsettled and other variables array as boolean. So we need to have the value in true and false format only. That's why we write down unsettled with the index as evaluation vertex equal to false and settled evaluation vertex equal to true. When this is done, that is we have done with the settled and unsettled array, we need to call the function for evaluation of the neighbors. We write down evaluate neighbors with the parameter as evaluation vertex. So evaluation of the vertex is taken this value and then passed to the function called as evaluate neighbors. As the name suggests, we are going to evaluate the neighbors. Neighbors are the next set of vertices near from the given set of vertex under consideration. We have done with the basic set of functions of the given program. Now we will calculate the minimum key vertex from the unsettled. Unsettled is your array which we have defined previously. Let us look at the function. We have private int get minimum key vertex from unsettled. Now this value is going to be unsettled 2 with array of the return type boolean. When this is done, then we need to calculate the minimum spanning tree value. So we defined a variable called as min with the value as integer dot max value. We have int min equal to integer dot max value. So this value is taken and given to the variable called as min. Then we are starting with the node. So we keep its value as node. We write down node equal to 0. When this is done, then we go for the variable called as vertex. We have for int vertex equal to 1, vertex less than equal to number of vertices. If this is true, then only we go for checking of the unsettled vertices. That is the vertices which we have not till visited. That needs to be visited and get the minimum key value from this set of unsettled vertices. We have if unsettled vertex is equal to true. So we have the vertex value parameter of the array unsettled. So we write down if unsettled vertex equal to true and key vertex is also less than mean. So it means we need to have the minimum value. For this, first we need to transfer the value of vertex to the given set of node. The value of node, we have defined it as 0. We take the value of vertex and transfer this set of value of the vertex to the node, and then we calculate the mean. We write down node equal to vertex. So value of vertex is transferred to the node. Then we have mean variable value, which value was previously as integer dot max value. Now we are going to take the key array value with the index as vertex. Key vertex, this value is going to be transferred to the variable mean. Hence, we have calculated the value of particular node and try to get the minimum value of the key vertex from the given unsettled node. Once this is done, then we need to transfer the value of node. That is, we need to return the value of node to the given set of calling function. So we write the return node. Once this set of functions are done, we have done with the evaluation of the particular node only. Now we will write down the function to evaluate the another set of vertices, that we called it as neighbor. Hence we write down the function name as evaluate neighbors. We write down public void evaluate neighbors with the parameter evaluation vertex. Once this is taken, then we go for the destination vertex. We write down for int destination vertex equal to 1 and it is less than number of vertices. Now we will calculate the condition for the settled. We have already done with the condition for the unsettled in the previous function. Now we will go for the settled values. We write down if settled destination vertex is equal to false, it means we need to visit this vertex. So we write down settled destination vertex equal to false. If this comes out to be true, then only we go for the evaluation of the adjacency matrix. We write down if adjacency matrix with the row defined by the evaluation vertex and the column defined by the destination vertex not equal to infinite. Infinite value is 999. So it means it is not infinite. It means it is still reachable. Then only we can calculate that particular part. If adjacency matrix, evaluation vertex and destination vertex is still less than the key vertex destination, still it is less than, then only we can calculate. If it is greater than, we have already done with the previous set of function. So we have key destination vertex value. This vertex value is going to be adjacency matrix with the particular row and column. So we are going to find out the cell number by writing adjacency matrix particular evaluation vertex, that is going to define the row, and this is going to define the column. This is going to be transferred to the key array with the particular index number as destination vertex. Once this is done, then we need to transfer the value of evaluation vertex to the parent array. We write down parent array with the index as destination vertex. So our evaluation vertex value is now transferred to the parent destination vertex. When this is done, then we need to make sure the unsettled array is going to be true. So we write down unsettled with the index as destination vertex equal to true. Previously it was false. So we are going to make it as compulsorily true by writing unsettled destination vertex equal to true. This is how you evaluate the neighbors by taking the evaluation vertex for the calculation. It is very important to have the set of conditions predefined to check whether the value of the vertex is settled or unsettled. We have defined the all set of functions which are needed to evaluate the vertex, calculate the logic of Prince algorithm, but we have not defined the function to print that particular spanning tree. So now we are going to write down the function to print the minimum spanning tree. We write down system.out.println. We take the source and destination and vertex. For this we are going to start with the vertex number 2. Vertex less than equal to number of vertices. Now vertex has to be start from 2 because first vertex is going to be always 1. We start with second vertex to have the destination. So we have index vertex equal to 2, vertex less than equal to number of vertices. Then we call the parent vertex that will act for the source. Then we call the vertex which will act for the destination, and weight is going to be called as adjacency matrix with the row number of the parent. We have parent vertex comma vertex. So this will define the weight. Like this we are going to calculate the spanning tree with the minimum set of value using the concept of Prince algorithm. This is how you define the function to print the minimum spanning tree. Now we will go for the main function of the class with the concept of try catch block. We write down adjacency matrix with the rows and columns. Then we have number of vertices. we take the scanner class objects called as scan to take the value from the user. Then we put our code into the try catch block. Let us begin. We have asked the user to enter the number of vertices. So we pass this value to the variable called as number of vertices. Once this is done, our adjacency matrix rows and size of the columns and rows is going to be number of vertices plus 1. So we write down adjacency matrix equal to new integer number of vertices plus 1. This will go for the rows, and number of vertices plus 1. This will go for the column. So we have defined the number of vertices to be taken from the user. That value is transferred to the variable called as number of vertices. Then we have the adjacency matrix defined as the rows and column with the value of row greater, or we can say number of vertices plus 1, and column also number of vertices plus 1. Once we are done with this set of value, that is, we have defined the adjacency matrix, we have defined the number of vertices. Now we need to calculate the value for the weight of the graph, or in other terms I can say the weight of the edges. This value has to be taken from the user. Hence we write down for int I equal to 1 to get the row, and to get the column j equal to 1 less than the value of number of vertices. We have adjacency matrix of particular cell as I j equal to scan dot next int. That is the values taken from the user and passed to the particular cell number. Then we check with the adjacency matrix value. We have if I equal to j, it means value of adjacency matrix is going to be 0. If adjacency matrix is going to be 0, then we have its value is infinite. It means that is not reachable. Once we are done with the source, destination vertices and the weight of the graph, now we need to create the object of the class and call the particular set of function to perform the prince algorithm. Let us begin with the logic. We have prince equal to new prince with the parameter number of vertices. So object is created with the parameter of number of vertices. Then we call the particular function, that is prince algorithm. Now the parameter of this is going to be your adjacency matrix. Once we are done with the prince algorithm, we need to print the minimum spanning tree. We have written the logic for the minimum spanning tree into the function called as print mst. We call prince.print mst. So we are done with the try block. Now we need to handle the catch block. The common error which occurs in the catch block is the user enters wrong input format. So we need to handle the exception call for the input mismatch format, informing the user that he has entered the wrong format for the either source, destination or the weight of the graph. This is how you calculate the prince algorithm. Basically, prince algorithm is used to calculate the minimum spanning tree. We have defined a class named as prince. Inside that, we have defined the number of arrays. Now this value of the array will be taken using the concept of constructor. So we have constructor named as prince with the parameter number of vertices. Using this reference variable, we are going to pass this value to the array using the number of vertices. So number of vertices is very important. Now this number of vertices value will be taken from the user, and using this reference variable, we will give these values to the use set of arrays. Now we will go for the set of functions for the prince algorithm. Let us begin with the first set of function. We have get unsettled count. This is to get the unsettled vertices count. We need to always have this count with us. In this, we are going to pass the array as parameter called as unsettled. So we start with count equal to 0, index equal to 0, and this will be taken till index is less than unsettled dot length. If unsettled index is there, that means it is not visited, or we can say we have not taken into the consideration. Then we are going to increase the count, otherwise not. So we have if unsettled index is true, then count plus plus. This will give me the count back. So we are going to return count. Let us look at the another set of function. We have prince algorithm with the parameter as adjacency matrix. Now this adjacency matrix is very important. We are going to put the value using rows and column. So this adjacency matrix array is a 2D array. we will take evaluation vertex as the variable. We are going to start with source equal to 1, source less than number of vertices, and destination equal to 1, and destination is also less than number of vertices. While this is true, we take the adjacency matrix value and pass it to the adjacency matrix using this reference. So we have this dot adjacency matrix, source destination equal to adjacency matrix source destination. So your adjacency matrix source destination value will be passed to this dot adjacency matrix. Once that is done, now we need to have the index value. For this we have for index equal to 1, index less than equal to number of vertices. So we have key index, so that is very important. Key value of index will be infinite. You must remember we have taken the infinite value as 999. So we have key index equal to infinite. Once that is done, then we check with the another set of indexes. We have key 1 equal to 0, unsettled index number 1 equal to true, parent index number 1 equal to 1. While this is done, then we check with the another set of values. So we have while get unsettled count with this parameter as unsettled not equal to 0. It means there is some unsettled value, or in other terms I can say there is some vertex which I need to visit. So we have evaluation vertex, then we are going to call the function called as get minimum key vertex from the unsettled. As the name suggests, we are going to go for the unsettled and take out the minimum key from that vertex with the parameter as unsettled. Then we are going to after that call the function called as evaluate neighbors with the parameter as evaluation vertex. This is how you define the Prince algorithm function, in which we are going to check with the settled value and also we are going to check with the unsettled value. Let us look at the another set of function. We have get minimum key vertex from the unsettled. As the name suggests, we are going to visit the unsettled vertex and take out the minimum key value from that particular vertex. For this, we have min equal to integer dot max value. So we are going to take the integer class value and going to put it in the max value. That will be treated as mean value. So our index will start from 0 and reach till the mean value. So we have vertex equal to 1, vertex less than equal to number of vertices. You must remember we have taken node equal to 0. While this is true, then we go for the if condition. We have if unsettled vertex is equal to true and key vertex is less than mean. You must remember we have mean value equal to integer dot max value. So we need to make the necessary transformation. This necessary transformation will be node equal to vertex. So your vertex value will be transferred to the node. Hence we write down node equal to vertex. After that we have mean equal to key vertex. So your key array which is of various indices. So we have mean equal to key vertex. So vertex value that will be starting from 1. So we have mean equal to key 1 that will be transferred to the minimum value. Like this we are going to make the necessary transformation. Once that is done, with this function we are going to return the node. You must remember in previous function we have written the count. Now we are going to return the node with the minimum key set vertex from the unsettled. Once that is done, that is one particular node is done, then we move to the another node. For this we are going to write down the function called as evaluate neighbors. So we have function called as evaluate neighbors. So we have the function called as evaluate neighbor. In this we are going to have the destination vertex equal to 1 and we are going to go till number of vertices. For this we need to have this count of settled vertices. So we write down if settled destination vertex is equal to false, that is that value is not true. So we have unsettled value in other terms. So we have settled destination vertex equal to false. While this is true, then we go for the adjacency matrix. That is adjacency matrix evaluation vertex and destination vertex not equal to infinite. You must remember infinite value is 999. So it is not equal. In that case only we can proceed. So we have if adjacency matrix evaluation vertex is less than also key destination vertex. These three conditions are true, then only we can make the necessary transformation. Let us look at the necessary transformation. We have adjacency matrix value. That adjacency matrix value will be transferred to the key array with the index as destination vertex, not the source vertex. You must remember we have the key destination vertex. Once that is done, then we will make the necessary transformation. transformation. This necessary transformation is we need to make the evaluation vertex change value, that is parent destination vertex now will be evaluation vertex. So one that is done, now we will go for the unsettled array set of value. We write down unsettled destination vertex equal to true. That is, now we are done with the count, we have done with the node, and also we have found out the node value. Now we need to go for the minimum spanning tree logic. For this, I'm going to define a function called as MST. Let us look at the function. We have the function called as print MST. As the name suggests, it is going to print the minimum spanning. In this, we are going to have the three set of value. This three set of value will be source, destination, and the weight of the matrix for reaching from source to destination. This is how you design the Prince algorithm. Let us look at the output. First, the user is asked to enter the number of vertices. For our simplicity, we are going to take only three set of vertices. Then the user is asked to enter the weighted matrix for the graph. As you can see, I've taken source as 1. So we have source 1, destination 2, and weight will be 2. Like this, I have taken another set of value as 1 source and destination 3. Since I have entered the weighted matrix graph as 3, the value comes out to be 3. Like this, we can find out the minimum spanning value from source to the destination using Prince algorithm. This is how you explain. This is how you run the Prince algorithm. You must remember, in case of Prince algorithm, we take a node, we check its set of values and also its neighbor value and reach the destination vertex. Thanks for watching this video. Please subscribe to Ekeeda channel.